Hello everyone, welcome to the today's session of course number Agro 123, that is Fundamentals of Agronomy Part 2nd. In previous lecture, we have discussed about evaporation, transpiration and factors affecting it. In today's lecture, we will discuss about evapotranspiration, potential evapotranspiration, effective rainfall and consumptive rainfall. In last lecture, we have discussed about hydrological cycle. What is a hydrological cycle? In short, hydrological cycle is the continuous movement of water within the Earth atmosphere. Evaporation is the loss of water from the soil surface. Transpiration is the loss of water through the aerial part of the plant. Then evapotranspiration is the combined loss of water from the soil and aerial part of the plant. Then we will discuss about consumptive use and evapotranspiration. The term evapotranspiration denotes the water transpired by crops and the water evaporated from the soil or water surface in the crop field, and the intercepted precipitation by crop aerial parts in any specified period. It is usually expressed as surface depth of water in millimeters or centimeters, or simply you can say that evapotranspiration is the combined loss of water through the soil and aerial part of the plant. Then second term is consumptive use of water. The term consumptive use of water by crop refers to the evapotranspiration together with the water used for metabolic activities by the crop plants. Evapotranspiration is often used simultaneously with the consumptive use, since the amount of water metabolically used by crop plants is hardly 1% of the evapotranspiration value. Among the absorbed value of the water by plant, only 99% about 99% of the water get transpired, and only 1% water is used for the metabolic activities of the plant. Then evapotranspiration may be expressed as evapotranspiration from crop field plus transpiration plus intercepted precipitation by crop plant lost as evaporation. In this pie diagram, you can see that evapotranspiration is the evaporation from crop field, transpiration and intercepted precipitation by crop plant lost as evaporation. Then consumptive use is given by evapotranspiration plus water used by crop plant for metabolic activities. Then classification of consumptive use of water by crops. Whatever the water get consumed by plants, on that basis classification of consumptive use is given. Consumptive use of water is classified as daily consumptive use, peak period consumptive use and seasonal consumptive use. Daily consumptive use, the amount of water consumptively used during 24-hour period is called the daily consumptive use. Whatever amount is utilized by the plant for their metabolic activity or is called as daily consumptive use. It is estimated usually to record the peak period use, rather rates of water by crops for formulating the cropping pattern. Cropping pattern is the yearly sequence and spatial arrangement of crops on a same piece of land in a given period of time, and to decide the water supply from sources during different period of cropping season. Then seasonal consumptive use, the amount of water consumptively used by a crop during the entire growing season or period is called the seasonal consumptive use. An estimate of seasonal consumptive use is period is called the seasonal consumptive use. An estimate of seasonal consumptive use is essential to evaluate and decide the seasonal water supply to a command area of an irrigation project. The consumptive use is expressed as surface depth of water in centimeters per hectare or hectare per centimeter. Then peak period consumptive use. The average daily consumptive use during a few days, usually 6 to 10 days of highest consumptive use in a season is called the peak period consumptive use. The peak use period usually occurs when the vegetation is abundant, temperature is high and crops are in the flowering stage. This is the design rate used in planning an irrigation system. In an irrigation project design, the peak period consumptive rate for various crops are considered. The peak use rate for a shorter period of 2 or 3 days is higher than that for a long period and is lower than the peak daily use rate. The peak use period is usually shorter in shallow soil and in soil with low water holding capacity. It is also shorter for crops with shallow root system. Conversely, deeper soils with higher water retentive capacity and crops with deep and extensive root system have longer peak use periods. Then, evapotranspiration. The types of evapotranspiration are potential evapotranspiration. The potential evapotranspiration denotes the highest rate of evapotranspiration by a short and actively going crop or vegetation with abundant foliage, completely shedding the ground surface and abundant soil water supply under a given climate. It integrates the evaporating demand of the atmosphere and refers to the maximum water loss from the crop field. Evaporation reaches its maximum when the crop foliage covers 50% of the ground and it need not completely cover the ground surface. Then actual crop evapotranspiration. The actual crop evapotranspiration refers to the rate of evapotranspiration by a particular crop in a given period under prevailing soil water and atmospheric conditions. It involves the use of a crop factor called crop coefficient while computing it from a reference crop, estimated by different empirical formulae or evaporation rates from evaporimeters. The evapotranspiration of crop varies under different soil water and atmospheric conditions and at different stages of crop growth, geographical location and periods of the year. Then reference crop evapotranspiration. Reference crop evapotranspiration to express the rate of evapotranspiration from an extended surface of 8 to 15 centimeter tall green grass cover of uniform height, actively growing cover of uniform height, completely shedding the ground and not short of water. The evapotranspiration is corrected for day and night weather conditions to potential evapotranspiration by multiplying with the adjustment factor C. The potential evapotranspiration may be computed with any one of the empirical formulae for a month or a shorter period using mean climatic data for a period desired. To find out the crop or actual crop evapotranspiration, the potential evapotranspiration values are calibrated by the different relationships. The actual evapotranspiration of crop, so computed, refers to the evapotranspiration of a disease-free crop growing in a large field under optimal soil conditions with adequate water and fertility and having the full production potential of the crop under the given environment. These are all about the evapotranspiration, consumptive use of water, potential evapotranspiration, then actual crop evapotranspiration and reference crop evapotranspiration. In next session of lecture, we will discuss about effective rainfall, consumptive rainfall, factors affecting evapotranspiration. So, thank you.